All right, let's get started.
Good afternoon.
How's HPE Discover Barcelona? Are you guys loving it? OK. Let me start by saying we are in an AI bubble. Do you agree with that? Nobody agrees with me? Scott doesn't agree with me at all. OK. I want to start saying, let's look back 25 years ago, right? We said, during the dot-com, internet is a bubble. It's been 25 years from then, and internet has gone places. Everything is connected today. It's become so good that it's basically ubiquitous. When the COVID happened, we didn't even know that we were not connected. We were connected everywhere. I think AI is similar in the sense AI is going to get there where everything we do will include AI. It's going to be like internet. So with me, I have Pawan here. We're going to talk about, we actually funded a study for this because we wanted to understand how fast AI is being adopted by the enterprise customers. So we actually funded a study with a third-party agency. And we're going to show you some numbers, what the enterprise companies are telling us. I think some of you might be part of the survey, too. And then Pawan's going to talk about, what are you going to talk about, Pawan? Architectures.
Yeah.
He's going to talk about architectures. So we're going to have a combination of the two things where we look at the business case for AI and how is everybody going to monetize AI and how is that going to impact the WAN network specifically. Because if you think about internet, what really happened was that you could look at the network and you could tell that internet is growing. And there were so many use cases that came up with that. I think AI is going to be very, very similar. So let's get started. So what did we do? What we did was we hired a third-party agency. It's called Omdia. And we went and surveyed 300 enterprise customers in North America and in Europe. Okay? We actually said, OK, other thing, the survey may not be enough. We picked some enterprise customers, and we did qualitative interviews with them, with the C-level people, to see how they're going to use AI in their companies. And then we talked to service providers and the cloud providers. So this is a very, very holistic study that we have done. And I'm going to share the data with you. We talked to various different verticals: finance, transport, logistics, manufacturing, so on and so forth. And we asked them, like, where are you in the AI adoption? And guess what? 98% of the financial companies said they are already adopting AI for various different outcomes. 98%. They said automation, productivity, improving customer experiences. These are the outcomes they were looking for. I'll give you an example. I have a friend who works on Wall Street. He's a CIO with one of the Wall Street banks. And basically what they did was they took all the prediction from all the previous IPOs to price new IPOs. Can you imagine this? Billions of dollars of decision being made from a business perspective using AI. Another example I will give, healthcare. I think the customer is not here, but this is a customer in Middle East. What they're basically doing is they're sequencing the genome for everybody in the population. It's the government-funded thing. They're sequencing the genome for everybody. So now when you go to a doctor, he has your DNA. You can pull the DNA and give you very specific treatment based on the genomics study they've done. So basically, what we're saying is that all these verticals, they may be in different stages, but this AI is getting adopted by majority of the verticals out there in the industry. Now, the second big question is, how is AI going to get adopted? Is it going to be, oh, that guy is giving me the AI, let me just go to one person and they will fulfill all my AI needs. For example, oh, I can go to Google or I can go to AWS. I'll just go to one place and give me all my AI needs. That's not the answer we got from the customers. So I'll tell you what the use cases are, first of all. What you see on the top are the functions. Agentic AI, generative AI, predictive AI. AI analytics. These are the different functions that the enterprise companies are looking to adopt. Then the second part of this is, how are they going to adopt these functions? Where are they going to go to adopt these functions? Okay? First, they said they're going to use SaaS models. They're going to go to companies like Salesforce or Adobe Firefly as an examples and buy services from them and use the AI models that they will provide. Second thing they said was that they're going to use the public AI models that are publicly hosted. You can talk about Gemini, you can talk about ChatGPT, right? So they're going to use those. Third thing they said was that they're going to also customize some of these models, but they're still hosted in the public cloud. Fourth thing they said was that they are going to use a multi-tenant infrastructure and buy capacity for the AI use cases. And last but not the least, they also said they're going to do private hosted AI. So what does this mean? So Antonio said on the main stage, which makes perfect sense to me, that AI is the perfect workload for hybrid cloud. Because clearly the enterprises is telling us that they are going to use multiple AI functions, and they're not going to go to one place to do those functions. They're going to go to multiple places to do those functions. I'll give you another example. I was in Japan last week. So today what's happening is majority of the AI capacity, majority of the training, for example, majority of the data centers that are being built in US. That's for training. But when we go to inferencing, which is how AI is going to be used, it's going to get a lot more distributed. It's going to be there in every country, in many places. And I'll show you why. What's the reason for that? The reason for that is this data that we got. So the first one is ultra-low latency. We asked them, what kind of SLAs are you going to need for your use cases? What kind of SLAs means, if you're going to have an AI use case, what is going to be response time that you will need for this use case to be fulfilled? 48% said that for the AI ops function, they're going to need ultra-low latency. Why? Because they're running business-critical functions here, like things like manufacturing loops, for example, which are really, really time-critical. And the question here was about 100 milliseconds. The question we asked was, do you need, basically, what's the ultra-low latency means? That means from the time the query is done, and the network latency, and the response from the inference engine, that needs to be less than 100 milliseconds. Then the 49% for AI analytics and 44% of agentic AI folks said, we will need ultra-reliable transactions, which means the connectivity cannot fail. It's so business critical that not a single transaction can fail as they use this AI function. Okay? Then you have other categories like business-grade latency, business-grade transactions. That's more where performance versus cost starts to come in. Now, what does this slide and the previous slide mean is that when you're looking to fulfill the AI needs of your organization, you're going to require connectivity to multiple different data centers. And what we've started to call this as a multi-data center connectivity, which means there has to be a gateway somewhere where everything becomes seamless. Your IT organization can say, I'm going to turn up this AI use case. I'm going to turn it up over there. I need that seamless connectivity to wherever I've picked this inference to be happening. And this is happening today. Bhavan will show some examples later. I'll give you an example of a service provider in US. This service provider is called Lumen. What they're basically doing is they built a brand new network, and they call this as the AI fabric. Okay? And they're connecting enterprise customers to various different cloud providers, and they're basically giving them the multi-DC connectivity and seamlessly managing that from a portal. So no matter if, as an enterprise company, you build your own network or you buy some connectivity from a service provider or a combination of those, this problem will have to be solved. Only then AI can be consumed. Now, this is also an important aspect of what the customers are telling us. So when we say, what kind of network connectivity are you going to look for? 96% said they're going to adopt dedicated connectivity for AI use cases. 96%. I was surprised at this data because, when we went to, for example, during the for the last many, many years, the SD-WAN has been growing pretty significantly, right? And doesn't mean the SD-WAN is going to go away. SD-WAN is going to be there. But when we talk about the AI use cases, basically the customers are telling us they're going to adopt dedicated connectivity. Even when they use internet for some of these use cases, they're saying, no, I don't want the best effort internet. I need SLAs for this internet connectivity, which means even if we're going to use SD-WAN, it needs to come with some guarantees of connectivity behind it. Edge inferencing, that's 87% have use cases for inferences to be hosted at the edge. So let's talk about this a minute. Inferencing will happen in many places. It'll happen in the big clouds. It'll happen in the colos. It will happen on the network edge. It will happen in the customer sites, right? But 87% of the customers say that they have requirements for AI use cases where the inferencing will need to happen at the edge of the network. Now, I want to take a history lesson back, when the 5G started, and everybody started saying, oh, 5G has a huge business case for the edge compute. Guess what? There was not a single use case for edge compute with 5G. 5G did enable low latency network, but 5G did not enable any use case. AI is actually the use case that requires the low latency for inferencing. Because now every use case becomes AI enabled over time. And many of these use cases are going to require that performance from a low latency perspective. And this is the real use case for the low latency and for the edge inferencing. There's another piece of data I want to show you. So what does it mean from a traffic growth perspective? How the traffic pattern is going to change? Let's take a very, very simple example. Are you familiar with the Meta glasses? Has anybody used Meta glasses? No, OK. So Meta has these glasses, OK? You can wear these glasses. You can walk around. And there is no AI capability in the glass itself. The glasses will stream the data to some place and give you real-time inferencing for the glasses. Now, imagine this. You're wearing glasses around. You're literally streaming video real-time to some place where the inferencing is happening. What's different between today, the video happens, and this one? Today, most of the video is downstream. In this case, the data is going upstream. Right? Huge change on the traffic pattern here. And this is going to be true for many, many AI use cases, that a lot more data is going to go upstream because you're going to constantly stream data for the decisions to be made. And that's different from the way the networks are built today. And the data basically shows now, during the internet era, right, we've done this numbers many, many years. So can you guess what the bandwidth growth was? About 40 to 50%. In the AI era, the models are showing the bandwidth is going to grow much faster at 140% CAGR. Because a lot of data is going to flow through the pipes for the inferencing. And this is because all the different things are there, because the machines, more and more machines will require inferencing. Is going to happen all the time. AE said on the stage, machines don't sleep. So this traffic will continue to grow. Now, obviously, the question is, what does it mean relative to the traffic profile today? Right? OK, I get it. This is going to grow 148% of 150%. What does it mean to the traffic profile today? So if you look at the graph on the left, the gray is the traffic pattern today of the traditional traffic, right? The video, the voice, the data, everything that we do today. The green is the net new traffic that AI is going to generate. We are at 2026 today. It's small percentage as compared to the overall traffic, but the growth rate by 2031, the AI-enabled traffic overtakes the traditional traffic. Now, we know how the networks are planned. For every organization, enterprise, service providers, cloud providers, 2031 is not that far away. I mean, this growth engine is already started. The second graph that you see on the right side is what I was talking about, the traffic patterns. The ingestion is what we call as upstream data, and distribution is downstream. For simple queries like ChatGPT queries, there's not that much different in upstream and downstream. But when you start to look at high-resolution videos and images, the upstream growth is way bigger than the downstream growth. So this is a massive change as compared to what is happening today. And even if you look at your now Wi-Fi routers, for example, campus and branch routers, if you start to see the traffic patterns, and if your organizations are already started to consume a lot of AI for the use cases, you will see the upstream growth higher than what it's downstream today. And this chart will become more and more significant as time goes by. So when we look at the overall picture of the network now, like I said before, where is the edge of the network? The edge of the network is wherever the AI engine is going to sit, the inference engine is going to sit. It could be sitting at the campus, it could be sitting at the network edge, or it could be sitting in the cloud, right? And the traffic patterns start to become more balanced, more symmetric, and there will be less oversubscription in the networks. So that's a big change from a traffic pattern perspective, right? And last slide on the data set. I know there is a lot of data that I'm sharing here. There are some qualitative data we also collected from in terms of the use cases. And across the board, and pretty much every customer has given the description of many, many use cases that they're looking to do with AI. And every company on the planet is looking to get more and more optimized using the AI engines. I think this growth engine has started, just like internet. AI is going to be incorporated in every use case, everywhere, everything that we do. Now, with that, I'm going to pass on to Pawan. Pawan, if you
Thanks, Amit.
OK, go ahead.
Thank you. So I'm going to talk about so everything Amit said, how does it impact the network, specifically the WAN. Now, before I go into the WAN architecture in the AI era, let's actually talk about what does it take when you are building AI clusters, whether it is for training or inference. You'll typically optimize it for various parameters, like time to first token that impacts the latency, or time per output token that impacts the performance, or teraflops per system watts, or teraflops per dollar, or concurrent requests, concurrent users. All of these do matter in terms of designing your cluster, but there are certain constraints that you have to deal with when you are building your AI inference cluster or any cluster for training or inference. The most obvious one that I'm sure you all know is power and space. So you may be constrained by the amount of power you have in your facility, or the cooling and other things that you have that will hinder in terms of how many GPUs you can use for your inference. And that will necessitate you to distribute. The other constraints can be on the compute and memory that you have in that location, or some of the service requirements that Amit talked about, where you may be constrained by ultra-low latency requirements that will necessitate you to distribute your inference clusters, or other considerations such as the local government restrictions on where the data should reside, or the sovereignty or compliance reasons that will require you to have compute and data in a certain location, in a geolocation, rather than distributing it in more geographical areas. So all of these do impact your design for how you deploy the inference clusters. Now let's take a look at the network view. This is like a 100,000 feet view of how the network looks like when you deploy your AI workloads in various data centers. Amit talked about AI being a true use case for hybrid cloud. Let me talk through a few blocks here. So you may be using centralized AI data centers. That can be a public cloud who is providing AI data center, could be like Google or Amazon or Microsoft, or neoclouds such as CoreWeave or Nscale, who is here. You may be using your AI workloads in any of those data centers, or you may have your own inference cluster that you have deployed, or you are distributing those, and it's probably a combination of all of these, where you have your own data centers, where you have some agents running there, or you have other workloads that are running in centralized data centers. It can be a combination of all of these. The responsibility of WAN is to connect machines and humans to wherever these AI workloads are running in the most reliable way, with low latency and lossless mechanism. So that's what the WAN network is supposed to deliver. But there's a key trend, there are a few key trends that are happening in this. One, the clusters itself are getting distributed. So it's one of the big changes is where these clusters are getting deployed. For example, if you are a transport provider and you are connecting to the AI data centers, a lot of these, for example, in the US or here, it may go through colos, like Equinix, for example. And Equinix is coming and saying, well, you have to go through my infrastructure anyway to connect to these infrastructure providers. Why not I provide the same infrastructure for you to deploy your inference workload? So we have seen this trend where colos are coming into the game and deploying the infrastructure for AI as well. And then we have service providers or telcos who are coming in and saying, well, I can provide the same infrastructure which is closer to the users, and you can run some of the workloads at my facilities also. So those trends are happening as well, where you have more options to deploy your workloads, whether it is in the public cloud or neo cloud infrastructure, or in the colos, or in other service provider infrastructure, or a combination of all of them. Now, while this is happening, if you are a network provider and you are an enterprise using these, what are some of the options in terms of WAN architecture for using these AI clusters? So the first option, which is obvious, and AE talked about it this morning in his talk, where he said 93% of customers are looking at upgrading their capacity to connect to these clusters, whether it is upgrading to 100 gigs or 400 gigs or 800 gigs. People are doing these upgrades as we speak. And it's not just about increasing the pipe, it is about providing intelligent service on these pipes, that is being AI aware and providing the necessary SLAs that includes quality of service and other parameters that is required for you to connect to these AI workloads in a more reliable way. Now, the other option, and this is actually my favorite, so I'm going to spend a little more time on this, and I know Amit also touched upon it, is about interconnect. Look, I don't think it is a news to you when I say the clusters are getting distributed. You absolutely cannot build in one location. Even if you are saying it's a massive gigawatt facility, it so happens that you cannot have a gigawatt facility in just one place. You may have a data hall with only 5 megawatts, and you will have to go to a next floor or next block, or maybe a few kilometers away, that can be tens of kilometers away, that you will have to interconnect those data centers. The typical interconnect use cases that we have seen, the predominant ones are generally about retrieving the data or storage that can be in a completely different location, that can be tens or hundreds of kilometers away. Or you may be doing storage replication. You have the storage in one place and you have to replicate it in a different location, which is a very common use case over the interconnect. We have also seen use cases where people are thinking about doing training, like backend, that is going through tens of kilometers. Literally, even here, I've talked to a few customers who are looking at connecting within a metro. Let's say there are 5 data centers, each with different capacity in terms of power utilization. They're like 50-kilometer radius, and they want to do training over this interconnect, where you have 10 or 20 different data centers interconnected, and you want to make it look like one, and you want to do training. Actually, if you have not read a blog, Dimitri, who is here, has written an amazing blog on what does it take to do training over a 50-kilometer distance interconnected data centers, and does the training work? The answer is yes, and please go read the blog. So we do have a lot of these options that are coming now, where interconnect is becoming more and more important. The other use case that we are also seeing is this prefill and decode disaggregation, where if you are looking at inference, you have these 2 stages in inference, where prefill is more compute intensive and decode is more memory intensive, as you know. So there are options, there are papers that are published where not only you do disaggregate, prefill and decode, but there are options where you can run them in different geographical locations, where you can run prefill in a more centralized location on expensive GPUs, let's say Vera Rubin, for example, right? And then you can take that KV cache, distribute in edge locations, and you can run decode on a RTX Pro, for example, right, on the edge locations. What that means is you need a very reliable, low latency, lossless interconnect. So what are the properties? Why do you need to care about interconnect? Interconnect is not an easy thing. You absolutely need certain things to take care of. IP or DWDM, you want to also make sure that it is secure. So you may need MACsec as an encryption. You need to be AI aware or RDMA aware, especially when you are using, for example, spraying, and you want to make sure that your interconnect is also intelligent enough to detect some of these traffic and utilize these accordingly. So you need to be RDMA aware. So a lot of these features need to be built in when you are offering interconnect. And as Amit said, Lumen is a very good example of one of our customers who is very focused on interconnecting these data centers. The third option is, especially this is very relevant to telcos, for example, where you can say, well, I can free up my facility. I have a lot of central offices, and I can get rid of my legacy telco equipment and free up the space. And let's say I have 250 kilowatts available in like hundreds of central offices. What do I get from that 250 kilowatts? They can say, well, if you are like, for example, you can partner with someone like Vultr or any other provider and say, you come into my facility, I'll give you space, and I'll give you more intelligent services like security, and you can offer the AI inference from my facility. Or the fourth option is do it themselves, which is what I said when I talked about AI inference getting distributed, where you can host the infrastructure at distributed locations and start offering these services. But what does that mean? It means that you will have to now figure out how the GPUs are orchestrated, how multi-tenancy and AI workflows and observability and all of those, you will have to now figure out all that stack that is required for you to offer inference as a service if you want to do it at your location. And so all these are options that are very much viable, which is increasing the capacity to connect to the workloads wherever it is offered, or offering interconnect as a service, or providing the space, or doing it yourself. All those options are something that we are seeing more and more, a combination of all the four that are happening already. So how does it apply to Juniper, and what are we doing? I mean, do we have the portfolio that addresses all of these trends? We talked about, and you have seen in various keynotes and the morning presentations, you have seen QFX launch, which we have Broadcom-based for AI fabrics. The data center interconnect that I just talked about, we have announced a great partnership with NVIDIA on DCI, and Scott will come on stage and talk about it more. Then we also have the on-ramp, which is very important when you are offering inference as a service. On-ramp or DCI, data center edge, is super important for everybody to come in to that location and then connect to these AI workloads. So that's what was the launch of MX301 was about. And then last but not the least is the security, which is super important when you're offering inference as a service. You absolutely need to make sure that the isolation for data for tenants are in place, which is what we offer on SRX-based platform. Let me actually, we have had a lot of technical jargons and talk, and I want to actually pause and maybe run an interesting poll, because I thought it's maybe a good wake-up call for those of you who have not had enough coffee. How many of you are Game of Thrones fans? Just quick raise of hand. Thanks. Enough? Okay, very good. Very good. So Game of Thrones, you have 7 kingdoms, correct? So there's so Targaryen king rules 7 kingdoms. So think of 7 kingdoms as 7 data centers, right? And us mere mortals, how do we go through these 7 kingdoms? We go through ugly, slow sea route, right? So it's very slow. But if you are a Targaryen king or a queen who died, unfortunately, but let's say you're a Targaryen king, what path do you use to connect to all these 7 kingdoms? Kiriti has an answer. You go through a dragon. So now the question is, what's the most powerful dragon in Game of Thrones? For those who raise their hand, come on, you must know this. What's the most powerful dragon?
Balerion.
Balerion. So it turns out that 2 years ago, we had this before the scale across and DCI and all. I mean, DCI was always there before all these terminologies were invented and people figured out these multiple data centers must be connected. Our routing PLMs, probably AE named it, I don't know. You have a Targaryen hair color also, AE. So, so we named our PTX as Balerion, not because of all these data center interconnects. So just wanted to say that Balerion, which is our PTX, was designed for all this connecting these 7 kingdoms, although we can connect a lot more data centers than 7. But that's really why it's really very important to have all these scaled across data centers and connecting them in a more reliable way. So let's say you have all of these products, and then you want to offer inference as a service. You absolutely, and then you want to offer it yourself, like I said, then you will have to figure out all the things that comes along with offering that service. And we have, I'm sure in some of the sessions here, you have seen this AI factory slide where HPE has a full stack solution for AI factory, which not only constitutes of the infrastructure, which of course has servers, the GPUs and storage, but all the network, the operating the network layer on the infrastructure that you see there. What we are doing now since the acquisition is implementing the Juniper-based network infrastructure, whether it is DCI, DC Edge, the security, into the AI factory reference architecture, so that when you are deploying these, you come with that network infrastructure along with other elements that are required. That includes the orchestration layer, your multi-tenancy, the GPU orchestration, the AI workloads and the frameworks for it, and also the security, lifecycle management, and observability, and all that stack. So what it means is you don't have to worry about doing it yourself. You can just take one of these AI factory reference designs along with all the solution and deploy it. It doesn't need to be a long, a long cycle of deploying it yourself. We are there to help you doing that. So the proof points, actually, Amit already talked about a few. I'm not just talking about slideware here. I'm going to tell you that these are happening as we speak. It's not just in the slides. Lumen Amit talked about Lumen as a great example of data center interconnect. They're a great customer of ours who are using our routers for interconnecting these multiple data centers. Then you have, I talked about distributed edge inference, where a lot of these colos are coming up with these offerings. Equinix is one of them, but Akamai, who is also a great customer of ours. Like if you are into, for example, if you want to do inferencing for content distribution, Akamai comes and says, well, why do you need to do inferencing somewhere else? I'm distributing the content anyway, so I'm going to host infrastructure to run the inferencing on my infrastructure, which also happens to be in Equinix. So Akamai does the same. In fact, they launched this. These are very recent, like 2-3 months, within the last 2-3 months. And last but not the least is TELUS, who is a telco, and they have the complete full stack AI factory solution from HPE, which they are using to have sovereign AI offering in Canada. So what are the key takeaways? Amit, I don't know if you want to come to the stage, but the key takeaways, AI impact on WAN. We talked through a lot of how does the traffic impact AI WAN, especially the traffic being more symmetrical than before, and how it impacts the WAN and how you have to redesign the architecture. The WAN for the future need to adapt to AI traffic more. So which means if you are a network provider, you absolutely have to look at the services more tuned towards AI. And we have all the right portfolio, end-to-end, compute, network, storage, all end-to-end portfolio to handle these requirements. So we are all in. The question is, are you all in? So with that, let me invite Scott to briefly talk about our partnership, especially when it relates to the interconnect and edge. And I want Scott to say a few words and what this partnership means to NVIDIA.
Yeah, thank you.
Yeah.
Appreciate it. So I'm Scott Snedden with NVIDIA. I lead AI networking at NVIDIA. I see a lot of familiar faces and old friends here. So what are we doing together around this front, right?
Yeah.
We've got NVIDIA ourselves, we have a whole bunch of networking solutions, even some that fit in the data center interconnect kind of realm, focused on that very, very high speed east-west or back-end network connectivity across distance. So, power is oftentimes the limiting factor to deploy an AI factory. You're often trying to figure out where to put GPUs in your data center, or maybe your data center scale has grown beyond a single location and the power envelope that's available there. And so we've developed a set of technology called Spectrum XGS that is a data center interconnect, using air quotes here, but very focused on extremely high-speed RDMA distribution, so connecting GPUs together in the same way we would use InfiniBand or Spectrum X Ethernet inside that building. But what we're creating here is a cohesive AI factory across distance, maybe 10 to 100 kilometer range. There is also very much a need for data center interconnect for data to AI factory access, for user to AI factory, for that cloud on-ramp use case that we talked about. And these are things that NVIDIA does not deliver. Yeah. NVIDIA has networking products, but we're really not a networking company. We're an AI company, and we develop the solutions to build that AI factory. And so the analogy I like to use is, if you think of an industrial factory, BMW in Germany, right, building cars, they may have an automotive plant. That automotive plant is probably a whole bunch of buildings somewhat near to each other. You're going to have some rail lines that bring the raw materials in, and then BMW builds the cars. Well, those assembly lines that are building cars might be in different buildings. There's probably some specialized rail system to transfer things from one line to the next within that campus of factory. And then there's another rail line that takes those finished goods out to the user. And so what we're talking about here is Juniper solutions, HPE Juniper solutions to bring the data in.
Yep.
NVIDIA solutions to move the tokens around between GPUs as we produce the goods, and then the output tokens get handed to an HPE Juniper solution to connect them back to the end user or take to the enterprise IT environment. So very, very complementary solutions, both very necessary.
Perfect.
And I think the two together is a really powerful thing.
100%.
Scott,
Thank you.
That's a great example, what you just said. And actually, this is a real example I heard from a customer that when you build an AI cluster, it has to run as fast, come up as quickly as possible. And in this scenario, the customer was transferring 2 exabytes of data from where the AI cluster is being built. An AI cluster is built wherever you get power.
Yeah.
It takes 2 weeks to transfer the data from one side to the other side. That much data needs to be transferred.
Yeah.
And for 2 weeks, if that AI cluster is sitting idle, that's cost.
It's expensive.
And
Yeah.
that's
Super
the,
expensive.
so that's the combination of this point-to-point data center interconnect and having a backbone to connect all these different AI clusters. I think that's the highway. The second part is also the customers have to consume AI, which means every device has to connect to the inferencing engines. And this is where the network edge starts to come in. And I think the inference edge and the network edge starts to basically come very much together.
Absolutely.
And this is how, do you believe that's how the monetization of AI happens?
And this is a really exciting opportunity for us to work together on, are these telco use cases, edge inferencing use cases, how that ties into a lot of the other network elements that are very much outside the AI factory. And so, yeah, I'm excited to come back at Discover next year and talk about all the great things that we've done together to solve exactly those problems, showing monetization of AI, and no bubble at all.
No bubble at all.
No bubble.
Real world use cases that we're driving.
Yeah. That was a rhetorical question. He knew the answer, that there's no bubble.
I mean, as we keep coming here every year, here and in Vegas, Discover, I think we're going to see a lot of these AI use cases actually become really, really real. And my belief is that some of the numbers that you saw on the graph, they're still conservative. And because we haven't scratched the surface on how much WAN networks are going to need to do as whatever NVIDIA is doing. And every use case becomes AI-enabled. Every device is going to stream data all the time. Humans are going to stream data all the time. I mean, we're going to need a lot more network capacity.
Networking is cool again.
And networking is cool again, yes. Okay.
Great.
Any questions before we end the day?
Okay.
Thank you.
Thank you so much.
Thank you so much.
Yeah.